The question is, obtain the inverse Laplace transform of this um, function. Now when you see such a function, if you see the power or the degree of the numerator and the denominator, if they are the same, then you have to do long division. Remember, the degree of the polynomial, degree of um, numerator should be less than the degree of denominator. Before you start the problem, you should always see the highest degree of the polynomial of the numerator compared with the denominator. If the numerator and denominator they are equal, then you have to do the long division. So let's do the long division. The denominator is s square, numerator is s square plus 2s plus 4. S square times 1 s square, so you're left with 2s plus 4. So now if you see here, so 1 whole number 2s plus 4 over s square, correct? That's how we do that. Now this is the same function. Okay, let me show you this same function. We have done just the division. Okay, and now we can easily find out the inverse Laplace of 1. What is the inverse Laplace of 1? If you see the map, this 1 is given. If you take the inverse Laplace, it's a unit impulse. Unit impulse means like sudden hammering or force, so it's an impulse. So it's very easy. So if we take the Laplace inverse of 1, which is impulse, this is a symbol of impulse, which is delta in time domain. So let's worry about this portion. So I'm gonna split it up now as here. I'll go back and combine this delta d, is not a big deal. So you can write it down as 2s over s square plus 4 over s square. So now this s is cancelled by s square, so you're left with 2 over s plus 4 over s square. So now if we are in the proper form, so take the Laplace inverse here, take the Laplace inverse here. So what is the Laplace inverse for 2 over s? In order to do that, I will look at this function 1 over s and the unit step. If you take the Laplace inverse Laplace of 2 over s, it is similar to like 1 over s. Take the inverse Laplace, it is a unit step. So or in the Laplace domain, it is s is s is at a 0 location origin, and in the time domain that it is a step function. So this is our time domain, this is our Laplace domain. Now over here, this is 2. And how about 4 over s square? So let's go over here. The denominator is squared, so you go over here, it is t. Okay, so I'm gonna write down here 4t. So now I'm gonna combine the whole function. So f of t equals to 3 terms. The first term is, don't forget this term. Okay, first term is delta t, which is impulse. Second term is a step function 2, which is, these are just, you can write down like this, 2 starting at time 0 origin, and 4t. This is also a step function of scaling factor 2. This is how you will solve it. Or if you don't need to write down, it's okay. It's okay if you write down like this. I will still accept this answer. Usually it is a good practice, you know, sometimes the function is starting not from right at the origin, like okay, like if I start right at the origin, this is good, but sometimes if it is starting over here, so it is a delay of 2. So how would we write down the function? Suppose this is 0.5, it's not according to the scale. So this is, one is starting at location time origin t, and the other one is starting as 0.5. The magnitude is 0.5, but the time is delayed by 2 seconds. This is how you write down the delayed function. But I'm going extra beyond the question,